So what are those basic PC system parts that we've been talking about? Again, there could be many of them, but we're going to keep it simple. In general, a PC system needs to have a central processing unit, or a CPU, a monitor, a keyboard, and a mouse. We're going to talk in depth about CPUs, keyboards, and mice. We're not going to talk much more about monitors. Remember that the central processing unit, or CPU, is something that we'll be talking about, and it can also be called the case, but we'll get onto that in just a second. When it comes to monitors, keyboards, and mice, we have several different versions and they may look different. Here we can see two examples. On the bottom we see an older model called a CRT. Basically they're big and bulky and they were around for years. But they've pretty much been completely replaced by monitors that look more like the one on the top. Again, they could be different colors, different sizes, but the one on the top is known as a flat panel. It's much skinnier, much lighter, sleeker if you will. They both do the same thing. They allow us to see what's going on the computer, or what we're typing, what the computer needs from us, and so forth. Keyboards are input devices that we use, and these are two kind of specialized examples. On the top, it's called an ergonomic keyboard, and we'll talk more about these later, but it's kind of split, a little bit different than a typewriter would be, so that it's easier for people who do a lot of data entry and less wear and tear on their hands. On the bottom you see a gaming keyboard. Now it has all kinds of extra little buttons and it even has red on the keys instead of a typical black and white. This has a lot of extra things specific for gaming. Not necessarily appropriate for a business environment, but if you need to work with gaming and all the different things that have to do with that, this is the perfect keyboard for you to use. Probably the simplest type of hardware that we have is the mouse, and we'll again talk about the mouse in a later section. But a mouse is a pointing device, and we can point and click, and here you just see a couple of versions. They all do the same thing, even though they look very different. All right, let's get into the nitty-gritty, that central processing unit, or the CPU, or what some people call the case or the box. This is the box that sits on your desk or on the floor. It might be upright or it might be sideways. It just depends on what type you actually have. It also may be integrated into the monitor. Some of the computers these days actually put the CPU components on the back of the monitor, making the monitor a little bit thicker, but then you don't have to worry about the box. The CPU is really the brains of the system. This is where all of the computing magic really happens. It has all the circuitry and electronics as part of it. What we can see on this particular screen are several examples of CPUs. They all do the same thing, but they do look very different. On the left is probably your most traditional looking CPU. It's a little bit wider, a little bit taller, very chunky if you will. The second one is a sleeker model, a little bit more narrow, something that we might call a mini tower, whereas the one on the left could be a full tower. The third one is actually a gaming machine, and it has all kinds of nice little lights and things that light up on the inside, makes it more exciting for people who are gamers. And on the right-hand side, we have a very small one that can sit right on the desktop. All of these do exactly the same thing. They have different potential. We'll talk about what that is in just a few minutes, but they're all the brains of a system, even though they're different sizes, different shapes, different colors, and so forth. So what's actually in the box? Well, actually that's pretty easy. The CPU can contain many different components or parts, but the most important parts we've listed here. A CPU has to contain a motherboard. It should contain a hard drive, something called RAM memory, a power supply, a fan, and it could have things known as sound, video, and network or modem cards. We're again going to take these kind of one step at a time. What we won't talk about anymore after this particular slide is the power supply and the fan. Obviously, a computer needs to have a source of power, so there is a plug or an outlet in the CPU, and it also needs a fan to keep all of the components cool. Those aren't things that we normally worry about though, so we won't discuss them any further. We will discuss these other components though. Maybe one of the scariest things and the most technical that we'll talk about is the motherboard. This is where we have all of the circuitry. This is the computer's primary circuit board, and there literally can be thousands, if not millions of pieces on this one little piece of electronics. The primary components though are the actual computer processor, which we'll talk about in just a second, slots for RAM memory chips, the controlling circuits that allow the computer to recognize what a mouse is, a keyboard, a disk drive, and a printer, and what it should do with it, and then slots for other types of cards that we just mentioned, like sound cards, video cards, network cards, and modems. Probably the most important component, though, of the motherboard, and really of the computer as a whole, is known as the computer's processor. There are many, many different brands, models, and speeds. And the reason I mention this in a fundamentals course is because if you're going out to purchase a computer, you need to know about processors so you can make a good choice. The processor determines how much data can be processed at any one time and how fast it can be processed. Common brands include Intel and AMD, and within those two you also have different models like Celeron, Pentium, Core 2, Athlon, Turion, and Phenom. Many current processors actually have more than one processor in them, and these are sometimes called dual or quad-core processors. So on your computer and on your motherboard, you'll have one processor. But if you have a dual-core processor, it actually has two processors in one, and if you have a quad-core, it has four. But what about the processor's speed? Well, it's not quite as clear-cut as just saying, just tell me what the speed is. Here's why. The type of processor can be faster or slower than the same speed, but a different type of another processor. Let me give you an analogy for that. Let's say that you and somebody else are supposed to both go to the grocery store. You both can drive exactly 35 miles an hour from the time you start till the time you get to the store, so your speed is the same. But if you know a direct route to the store, and your friend doesn't know that route and has to go a little bit longer way, obviously you're going to get to the store faster than they are. This is the same thing that can happen with the processor. Even though technically the processors are driving, if you will, at the same speed, if they process things differently, then one may actually be slower at processing the same amount of data than another. The speed is determined by how they actually process the data, and that's measured in gigahertz. The bigger the number, the faster it is. Let's look at some examples. When you're buying or looking at the computer's processor, you need to look for several things. First of all, who's the manufacturer? What's the model? How many processors does it actually have? Remember that single core, dual core, quad core we talked about. And then what is the actual processor speed? Let's look at a specific example so you can see how you would compare processors if you were purchasing a computer. I've listed for you 4 actual examples of processors that you can buy. You'll notice that the manufacturer is the same. These are all Intel processors, but they have different models. There's a Celeron 3-core 2s, 2 that are duos, 1 that's a quad, and then a whole variety of speeds. So let's analyze these a little bit. The first one is an Intel Celeron 450 2.20 gigahertz. Now you may not know this, but a Celeron is kind of an entry-level processor, if you will. So just remember right now, it's a single-core processor, 2.2 gigahertz. If we compare that to the second one, it's also an Intel, but this is a Core 2. The Core 2 processors process things differently, so it automatically makes it a little bit faster than the Celeron. In addition, it's also operating at 2.93 gigahertz, which is a bigger number than 2.2. So it both processes things differently, which makes it faster, and its actual speed is faster. So the second one is going to be possibly a better choice. The third processor is also Core 2 Duo. So the only difference between the second and the third is that the first is at 2.93 gigahertz and the second is at 3.33. That would make the third one faster. The last one is still a Core 2, but this time it's a quad processor at 3.0 gigahertz. And this is where it gets a little bit interesting. It is a quad processor, but notice it's a little bit slower. So the question would be, based on the type of computing that you do, what types of activities you're doing, does the quad processor make it faster than the Duo, or does the 3.3 gigahertz make the Duo processor a little bit faster than the quad? It's not an easy answer. What we actually get in this particular scenario is that either one of the last two are going to be really, really close. If I'm doing some heavy-duty business computing or some things with audio and video, I definitely want to stick with one of these two processors as opposed to the Celeron. Why doesn't everybody just get the higher-end processors then? The reason is, of course, the price. A quad-core 3.0 gigahertz processor is going to be significantly more expensive than a Celeron. But you know what? If you're using a home computer and you're listening to a little bit of music, maybe browsing the internet, doing some word processing, the Celeron processor is going to be just fine. You probably wouldn't even notice the difference between these four processors. It's only for higher-end multitasking where the higher-end processors might become an issue. That's really what I wanted you to know about the processor itself. And I know it gets a little bit technical, but hopefully you can now see that we have hardware, software, and operating systems. Within the computer, we have the CPU or the box. On that, we have the motherboard, and the motherboard contains the processor, and that's what may be important for you, at least initially, when you're going to look at a particular computer.